Hello students, welcome back. We had been discussing the divisibility tests, and one of the motivation was associated to the trial division and prime sieves, but the divisibility tests are actually standalone topic. The prime number testing is just one of many motivations of this divisibility test, to tell the truth. And according to a textbook, this divisibility test appears way later, but I decided to talk about here because, hey, we are doing computation, so why not do some more computation here? That was my thought. We went through these. Divisibility by 2 or 5, just look at the last digit because 10 is divisible by 2 and 5. So that's divisible by 205, so that's 0, congruent to 0, modulo 2 or modulo 5, and we need only the last digit. Divisibility by 4 and also by 24, remember 100 is 4 times 25, so we have a multiple of 100 which is congruent to 0, and then last two digits. So that's how you can test for divisibility of 4 and 25 using the last two digits. You can do the same thing for 1000 equals to 8 times 125 and last three digits, and then this part divisible by 1000, so congruent to 0 modulo 8, and check only for the last three digits. For 125 it's not that useful, but for 8 this kind of thing can be useful. And you can do the same thing for the divisibility by 16 or 32 or more. But hey, what's the point if you have to take too many last several digits? Anyway, that's a kind of divisibility test that we talked about initially, and that's type 1. And then we talked about type 2, sums of digits. Sum of integers adding up to a multiple of 9 or multiple of 3, and those are because 10 can be decomposed into 9 plus 1. So take one digit out, and then 9 is congruent to 0, so that goes out. Multiply by 1 only, then what's left is just last digit and what's left. Do the same thing as I highlighted here. 4 was there before, take 2 freshly out, and then we have times 10, but that can be decomposed into 9 plus 1. 9 is congruent to 0, so times 1, what do we have? Well, same thing as before, taking the next digit out. Do it again, take the next digit 3 out. Do it again, take the next digit 8 out, and eventually you're going to run out of everything, and then you're going to get a sum of all digits. And then check whether that's congruent to 0, modulo 9 or modulo 3. Up to this point, I believe most students are already familiar, I think, or I hope. Now, how about this one? This one, probably a little bit less. Divisibility by 99, which is not very important, but divisibility by 11, yeah, that's useful. And we are looking at the sum of two-digit blocks starting from the end. So for example, we have, like this. Take last two digits, 24 out, and times 100, and decompose 100 into 99 plus 1, and this is congruent to 0. So multiply by 1, the end result is 24, and then the rest. Do it again, we take 83 and the rest. Do it again, next two digits, and the rest. And then what if we had odd number of digits? In that case, Okay, all right, that completes. We have two-digit block, two-digit block, two-digit block from the right, and then this one has only one digit, or you can consider 0, 1. So two-digit blocks are counted from the right, not from the left, always from the right. Remember that. And then you can do something similar to three-digit blocks. Then you're going to get the divisibility by 999, which is not very important. But the divisibility by 37, yeah, that's going to be useful because 999 divided by 37, what is it? It is 27. So divisibility by 27, yeah, that's not very important because, divisibility by 9 and then also by times 3. So 3 to the third power, I'm just repeating it many times, but divisibility test by 37, wow, that's useful, especially when this number has humongously many digits. Goes like this, 1000 and then 3 digits, decompose it to 999 plus 1, and this is congruent to 0. So we have just 3 digits left. Do it again, take another 3 digits. Do it again, take another 3 digits, and then find out what's the remainder, modulo 999 or modulo 37. In all those, there was no sign change, just plus, plus, plus. All right, now let's go to divisibility test 2. Maybe I should have named test type 3. Sum of digits, yes, but this time we have alternating sign, plus minus, plus minus, plus minus. And that's for 11 and 101 and 1001, 7 and 13. 7 and 13, those are going to be quite useful. Let's begin with 11 case first. Decompose like this, 10 and then last digit. And then previously what did it do? We did, oh no. Previously we took 2 digits out. Let's go back here. We take 2 digits out and 99 plus 1 we decompose like that. No subtraction. This time, just 1 digit out, that's easier, but 10 is 11 minus 1. We write like this. And then 11 is congruent to 0, mod 11. So this is the end result. Take 4 out, what's left with opposite sign. Let's do it again. Here, 4 was there before, and then this negative, take the last digit out, and then 11 minus 1. And then 11 is congruent to 0, and we have minus 1, and here's minus, so we end up with sign change, positive. The result, 2 minus 4. Do it again, 2 minus 4 plus 3. Do it again, 2 minus 4 plus 3 minus 8, and so on and so forth. Starting from the right, add up all the digits, but with alternating sign. Plus, minus, plus, minus, plus, minus. And if this thing is congruent to 0 modulo 11, then the number originally is congruent to 0 modulo 11. Can you actually see that? Well, I wouldn't bother. Yeah, that's left to you. Now, compared with trial division by 11, is this really easier? Yes, it is. Especially considering if this is really big, then also if you cannot use calculator, then yes, it's effective. Divisibility by 101. This time we use alternating sign, yeah, but with 2-digit block. You see, 124, and 100 is 101 minus 1. So this is 0. So we have 24 and multiplied by 81, we have sign change. We have negative. Do it again. takes last 2 digits out, so we have negative, and then we have sign change, so this becomes positive. Do it again, sign change, we have positive 68. Do it again, we have sign change, negative 57, and so on. And in the end, please check whether this is congruent to 0 modulo 101 or not. 101 is prime, I think. It's prime, right? Yes, it's prime. So it's useful by itself. Okay, let's do it again. This time let's consider 3-digit blocks with 1001. And 1001 is divisible by 7 and 13. Let's see. 77. So 1001 is 7 times 13 times 11. Yeah, okay, all right. But divisibility by 11, we already have it here in the first line, so it's not that important. But divisibility tests by 7 and 13, those are going to be useful. And the idea is 3-digit block. Let's see. Take 3 digits, 324 out. We have 1000 here, but that's 1001 minus 1. Now this one is 0 congruent 1001. So that goes out, multiply, we have negative 1 times that, so we have sign change. Do it again. I have last 3 digit, negative, and we have sign change, plus. Do it again, we have last 3 digit and sign change, negative 7. And that's it. Calculate and then see whether this is congruent to 0 modulo 101 or not. Or check whether that's congruent to modulo 7 or modulo 13. Now, divisibility by 7, it may be easier if you actually just go ahead and divide by 7. Even with long division, maybe, or maybe not. I don't know. I don't want to try this with long division. But long division by 13 probably is going to be easier this way. And if you have more digits, instead of this many digits, if you have something like 12 digits, 15 digits, then this kind of method will be much better. Of course, all these kind of divisibility test methods were developed, many hundred years ago, as a matter of fact, maybe thousands of years ago. I'm not completely sure about the history about these, however, and it could be an interesting project for you, some histories about these kind of things. All right, that concludes a bunch of divisibility tests. And as for exercise problems, I'll give you only recommended exercise problems. I mean, it's really, there's no point requiring these kind of problems because if you punch in the calculator, you're going to get the answer. So there's no way for me to police that. So I'll just keep it as an honor system. Then this kind of problem should go more toward recommended problem than required problems. Do you have an example problem? Okay, use divisibility test to factor 48,873 manually. Is this something I can do relatively easily? Divisible by 3 and by 11 by adding those up? Adding those up, 3, and then alternating addition with alternating sign, divisibility by 11. And as for the others, manually try up to square root. Okay, tedious, you can do it.